Dun, dun, dun. Welcome to the most exciting part of today's conference. It's our lightning talk. Woo!
How's everyone's day one been so far? And please make noise to show how excited you are to be here. Yay!
So, hello, I'm Chuck, and maybe you have seen me before. I'm hovering around, come and say hi to me. And I'm your host today, and also my partner,
Lorena Mesa.
Woo.
I love that Chuk literally came from giving a talk to just now running lightning talks. That just goes to show you how amazing our community of volunteers are. Again, this is a community. All of us are pulling our weight, and I just want to say thank you all for being here today. You're all fantastic.
Woo! So, I know that some of you may be your first time watching a lightning talk, joining a lightning talk session, so you don't know what's going on. I'm going to explain it to you. So, for the following sessions, we have a lot of speakers. All of them, we have 5 minutes to give the talk. Since we are in PyCon US, we are all very supportive, so please remember to be supportive and comply to Code of Conduct. And so how are we going to hint that the speaker, oh, you have used up your 5 minutes? So what we're going to do is that when it's like only 30 seconds left, we would do a very gentle clap. It's not a full clap, it's a gentle 2-finger clap. So could we practice it now? Yes? Oh, perfect, you're doing very well. And then, when the speaker should actually finish the sentence, we would give them a round of applause to thank them for the lightning talk. Can we try that? Woo!
Fantastic. So another thing, too, that we would just like people to know, for anyone who has a Python event, be it a meetup, you organize a regional conference, etc., on Sunday, we're collecting slides. Each person will have 1 minute to introduce their event. And you can send that to me at lorena@python.org. So that'll be on Sunday during lightning talks. And I'm going to go ahead and pass it now over to my MC.
Yeah, so Katie, welcome. So that's your slides, and you can start your lightning talk.
All right. Hi, my name's Katie, and I'm going to be talking about using Python to rescue some animals, though you can probably apply a lot of this to whatever nonprofit, cause you're passionate about. So just a little bit about me, kind of boring stuff. I do have to give a shout out to my actual paid job, Capital RX, because they're the reason I'm here, not the rescue. That's just a volunteer job. But yeah, there's my GitHub and Mastodon there. So the reason that I'm up here, puppies and kittens, they're very cute. How can you not like them? If you happen to live in the Dallas area, these are all actually pets on our website right now. You can apply to adopt them on your phone if you would like. So this is kind of my passion. So unfortunately, though, it's a nonprofit, so it can't pay too much. But the general idea, when you think of an animal rescue, you might think of them, in like Petco with an adoption event and people walking by. Well, the reality is those adoption events, you might get seen by a few dozen people, whereas these are the numbers that we get on our website. For just 1 week, we have 6,000 views of the adoptable dog listing. So in reality, the majority of traction that we get is going to be online, not at these adoption events and things. So, some things you have to consider when you're making software for especially smaller nonprofits. Cheap is good, free is even better, of course. Free is always good. It's usually volunteer labor, which means that the software needs to be low maintenance. It needs to just work for a long time, because it might be a while before someone can fix it. And you can bribe people with building their GitHub, so make it open source for that reason. So here's the general crux of what we often are dealing with. So we have the rescue software, Shelter Love, which is just a third-party software, but they do have an API. And then we have our website, which is built in WordPress. So the question is, how can we get from one to the other? And The AWS Lambdas in Python are a very easy way to do that. So you can do that with any nonprofit, of course. Literally, we still haven't been charged for a Lambda, and it runs every hour, so it's just about as cheap as you can get. So we take the Shelter Love API, and it's a CloudWatch event on AWS. It triggers a Python Lambda once an hour, and then that sends the pets to the WordPress API on the website, and they show up in the nice, neat, arranged thing. Usually these shelter softwares, they have you know, like iframes you can put on your website, but I think we can all agree that they don't look very good. So this looks much better. Lambdas are super easy to work with. You can literally edit the Python code right there in the AWS website if you want to. We use them for all kinds of things, you know, go into Pet Finder, all that kinds of stuff. And then recently we actually opened a physical we call it the adoption container. There's no pets that stay here. Basically, we have a staff member there, and fosters can bring their pets there, and it's at a brewery. That big blue building is Community Beer Company. And then inside of that, we have these giant touchscreens that were donated. So we run a React app on that, which connects to Fast API plus Mangum. I don't know if you've ever seen this, but using Fast API plus Mangum is stupidly easy. So this is the entire code for getting a pet from our DynamoDB database. It's really, what, like 10 lines? I mean, it's nothing. So it just makes it super easy to spin up. And then our next thing on the horizon is rescue is kind of shifting in the respect that it's not so much panicking when an animal's about to be euthanized and grabbing it. It's more preventing the animals from entering the shelter in the first place. So the way that we're doing that, it's this new DIGS program where our volunteers and staff basically assist someone with rehoming their pet responsibly. And I built a very hacky version in Airtable. It's buggy, it's expensive, but it's the perfect use case for Django. So here we're working on Django. You can look it up there. Some takeaways, they need your help. Highly skilled volunteers are always needed. And here we are.
Excellent. Thank you so much, Katie. So I'm a very big, proud cat mom. I have 2 Maine Coons, and I'm getting a 3rd one next week. I guess 60 pounds of cats is enough for me. But now taking it on to a different trajectory, we're going to have our next lightning speaker, Burnett, talk about a fantastic library they help work with. Take it away.
Hi, everyone. Yeah, so as you can see probably from the slides, I work at Bloomberg. And Bloomberg does love open source. You may have heard us that last year we released open source, our awesome internal tool called Memory, which allows you to track your memory usage and detect memory leaks within your application. And we followed that up this year by releasing PyStack, which is a great way to check what your application is doing when it's hanging without having to start it in debug mode. And bonus, it also works if your application crashes or stack fails or any of something like that. And what sets these tools apart from some other ones that you might have heard about is that these tools actually work also not just for your Python code, but also can inspect information at the C level. So you can see the stack trace both for your C variables, but also for your memory leaks that are at the C level for your C extensions. That being said, today what I really came here to talk about is Tux. This is another tool that mostly is made possible with the help of Bloomberg, because I do a lot of work on this project, and I would say around 50% of the effort I spend on this project is done during my paid work hours. And for those of you who don't know, Tux is kind of like a Python environment orchestrator tool. It's mildly popular, having around $18.5 million a month. And if you haven't seen one, basically what it allows you to do, that given a kind of like an ini file configuration, it allows you to describe how your project setup a test environment should be set up and run. So for example, here you can see an example in which one I define 2 test environments, one for Python 3.11 and one for Python 3.10, and also like a type checker environment. And as you can see, for the test environments, I have some dependencies like PyTest and PyTest, and then I just invoke PyTest with some arguments. And for the type checker, I actually install PyTest and then similarly invoke PyTest. And once you do have this configuration file, you no longer have to remember to create virtual environments, activate them, install stuff into it. Tux will take care of you, all of that. Now, in 2021, I gave a lightning talk here about Tux for Call to Arms. Tux has been released around 12 years ago or whatnot, with a lot of packaging details that were true 10, 12 years ago, but the packaging environment moved around. So it came to a point where it was kind of like work for us to try to rewrite everything from the scratch, and that's how we released this December Tux version 4, which actually now is a complete rewrite from base down. It took us some time to actually fix all the bugs, and after 44 releases of the 4.0.0, at version 4.4.4, that's a good pun also for some status codes, we have finally managed to get to a point where we actually were stable enough that I could say that it's in a stable point. So what kind of like improvements we added with Tux 4? Because as I said, it wasn't just about rewriting the tool, it was more about fixing some long-standing issues and adding more better usability and functionality to the tool. One of the functionalities we added is sub-comments. Rather than trying to put everything under a single comment and having different flags do different things, now we grouped around the functionality and we have sub-comments such as run in parallel, list the dependencies of the environments, list the environments, create developer environment, show me the configuration of a given environment, even run a comment within a Tux environment. Okay? So for example, if you want to check what is your Tux environments defined within your Tux file, you can basically just use the list command and that will help you achieve that. Or you can use the run command to actually run tests. For example, here you can see when I type in tux run -e type, that will actually kind of like install my project dependencies, then create an isolated build environment for me in which it builds my project, then installs that project into the test environment, and then runs the testing, in which case the test here is actually just calling mypy and seeing that everything works, and in the end it reports kind of like a report. Now this is good if you want to run a single environment, but if you have like many environments defined for a project, you can even run them in parallel, like you can see here. You can see with just one command, it created and run the test suite for like many Python versions, many different kind of tests. So I can see what passed, how it works, what is the final coverage report, stuff like that. Another new feature that we added is now we have much fancier colors. In Tux 3, this was all black and white, but with Tux 4S now you can see like we have nice color indicating which environment is doing what and what command, and also just the output is much more colorful, much easier to read what's happening. Okay? Another functionality we added is basically being able to run Tux, set your own defaults, and also now we can define your Tux configuration in a Python file. Okay? And just one more final thing. I also made a few other projects, and you might want to know about virtual, and we just recently dropped Python 2.7 support. So if your CI started to break, you can blame me. So, thank you.
Thank you so much. And I love talks, by the way, so thank you. And we have our next lightning talk, also very exciting. It's about sorcery. So thank you so much. And Brendan, the stage is yours.
Thank you. Hi, I'm Brendan. I'm going to give a quick demo of code understanding, which is an upcoming feature of Sorcery. So firstly, what is Sorcery? Sorcery is an IDE extension and command line tool that refactors and reviews your code and helps you enforce best practices. We like to describe it as a pair programmer and real-time code review tool. Let me show you an example. Here's a function that opens a file, reads some lines, closes the file, and returns those lines. So you might notice that we can use a with statement to improve this. And Sorcery notices it too and highlights the code. If we hover over that, we get a description of what it's going to do along with a diff of the change. And then we can accept that, and here's our fixed code. So Sorcery works for Python and JavaScript. It's got loads and loads of built-in rules, and you can write your own rules. And you can use those to apply bulk refactorings, find, fix, and prevent bugs, and to enforce best practices. So it runs in VS Code, PyCharm, Vim, any other IDEs you can think of, and this command line tool, and you can use that in CI too. But what I want to talk about is understanding code. So hands up if you write code. Hands up if you read code. And hands up if you read more code than you write. So according to some estimates, we spend 1 hour writing code for every 10 hours of reading code. So there's lots of great tools like Copilot, Tab9 that help us write code more quickly. But what about reading code more quickly and understanding it better? Wouldn't it be great if there was a tool for that? So that's what we've been building. So I want to show you a quick demo. So here's some code. Does that come up? Yeah. So imagine you're seeing this code for the first time. Now, what's this main function do? It creates a data provider, it gets a name, it gets an age, and it outputs that. The question is, where does the name and age come from? Do they come from a database, from the command line, from reading a file? And where's the output go to? Is it printing to the command line? Is it writing to a file? So what we normally do is we drill into the code, and we spend loads and loads of time drilling into code, jumping around between functions, jumping around between files. But what would be great is if we could see a summary. So if I switch on Sorcery effects, we've got some emojis that are telling us what this is doing. So if I hover over them, so it's telling me it's printing to the console, and it's telling me it's calling the print function in the output function. It's reading from the console. It's performing a network request to get the age. And it's raising an unhandled exception. That's really, really important. So we need to put a try except handler somewhere. So having this information available allows us to quickly scan the code and understand it more quickly. This function here is pure, it has no side effects at all. And then we can see get name, reading the input from console. Here's our get age with its exception and reading from the network, and we've got the output. So that just makes it easier to read this simple file. But imagine you've got a massive code base. You have to spend ages digging around to understand things. And this gives you a high-level overview straight away. So, understand code more quickly and thoroughly. This is experimental. We're going to launch it in a couple of weeks' time, and we'd really love your feedback to make it better. And I really hope you will like it. So we actually have a booth, Sorcery. It's near the lunch tables, so quite far away from the entrance. And thank you very much.
I can connect with reading more code than I write. I wrote some code on the plane yesterday. I went to go read it today. I have no idea what I was writing. I think that just goes to show you, enjoy your time on the plane. Traveling already is what it is. All right, next up we have Darhas, who's going to be talking to us about science and data science environment management for teams. Take it away.
Hello, PyCon. My name is Darhas Patina, and I have been trying to install stuff in Python since 2008. I work for QuantSight, and I actually looked this up a few hours ago, and my first question on SciPy users in 2008 is about trying to install NumPy and SciPy from SVN, and how to do that. And I heard that there was this thing called python setup.py.install, and was trying to use it. So, data science environments are very annoying. They're hard to create, hard to maintain, and hard to share. And there are reasons for that, good reasons. Today I want to talk about some practical approach we've taken to do this. There are core reasons that things are hard and there's work going to that, but what can you do today? And I'm going to take a small detour because the reason we want to solve this problem is it helps us to collaborate among teams. This is my current boss, Travis Oliphant. Some of you know him as the creator of NumPy and co-founder of Anaconda and stuff like that. At QuantSight, we're trying to experiment with LLMs and generative AI. And so we wanted to look at stable diffusion, and there's a nice web UI for that, automatic 1111. It is really annoying to install. But when you can install these tools, and when you can share them among your teams, you can do really useful stuff. Like, for example, this is our captain, Captain T. Oliphant. Or, he's actually more warm and huggy. So if we want, we can say, oops, I actually didn't run this. This is actually what Travis is really like in real life. Getting back to what the actual problem is, we've seen when we work with clients, when we work internally, Python data science, IT departments hate it. You either have two options which happen. Either they lock down the environment completely, you have a holy Docker image that, putting a new package in it takes like 6 months to a year, or you have the diagram we've all seen where everyone pip and conda installs everything and you don't know what's where, and you can't move anything into production. There are some best practices that I've learned over the years and people know about how you can do stuff, but it's very difficult to teach new users the exact best practices that will give them a stable environment. So we've built a new open source tool called Conda Store, and essentially we're trying to bridge that gap, and I'll go into a demo. We've basically tried to enforce best practices on the back end, but for an end user, we give them an easy interface. We just, I have, and we also added namespaces. So I have my personal environments, for PyTorch or TensorFlow or whatever, and I have environments for different departments. And like I did a PyCon tutorial 2 days ago. So for that, I made a tutorial environment that only the PyCon tutorial people could access. And with that, under the hood, we are allowing people to pin packages. But when we create it, we also automatically create log file. Oops, that's the log one. We also automatically create the log files, so you know exactly what's in an environment. We can auto-create the Docker image, and we version the environment, so you can always switch between environments, or if you're an admin, you can decide which environment is the active environment. And behind the scenes, we're just using all the open source tools you know and love. Like, we're using Conda environments, we're using channels. The whole point of this is most people just need their environment. They don't have the time or the patience to learn the best practices. So can we give them a tool that lets them create what they need and share what they need, but behind the scenes, we enforce the best practices. So this is Conda Store, and I will actually show you the environment which those images were made in. This is the environment, and actually you see, if you look, it took one of our engineers about 8 attempts to get a working environment, and we've had to pin various things, and also these are all the things which were installed as dependencies. These are the Conda channels we had to use, and if you look, it's not just Conda. To get this environment working, we had to use pip packages as well. So this took a long time to get working, but now this environment is available for our entire team. So that was my little demonstration of Conda Store, and if you want to go check it out, go to conda.store.
Wow, that's very, very good picture of Travis. Thank you so much. I really enjoyed that. So I think that we all have heard these 3 letters before. They're appearing in social media everywhere. The 3 letters are GPT. So what are you going to tell us, Ray? So please, you have 5 minutes, and the stage is yours.
Thank you very much. My name is Ray McLendon. I'm a data scientist, and I'm here representing botwhisperer.co. We actually offer different forms of educational content around generative AI for the rest of us, those that are not trying to build custom models or necessarily fine-tune anything, but allows us to get up to speed with a team of bots all communicating within minutes. And one of the things that we provide with our education are some fun little use cases that we play around with. So I wanted to share one today. This is a conversation I chose to have just yesterday with a large language model, and it's from my perspective of being a data scientist. In my job, I routinely go around asking for a data dictionary, and I guess not to my surprise, a lot of businesses don't take the time, or the devs don't take the time to actually produce a data dictionary for us. So that makes my job a little bit more difficult. So I figured, maybe I could get GPT to actually produce a data dictionary for me. So here, I'm just going to load up a little bit of data. When I started this off, it's product reviews, pretty openly wide available data. And then from there, I pretty much parse it up a little bit and dump into an actual conversation that I'll walk you through. And just for the sake of time, I'll try to parse through it for you quickly. I start off by just asking, what is a data dictionary? Who generally puts a data dictionary together? And what kind of format, what things generally come in a data dictionary? And if you've worked in a number of organizations, you will know that they all actually have a different answer to these questions. They all have different ideas of what a data dictionary is. Yet, I think the large language model did a pretty good job of explaining that. Next on, I ask it for an example. And from there, I realize, I'm not liking this format too much, so I have it kick it into an actual table. So this is an example that it's produced. So now I'm ready to have my next little bit of fun. I tell it, I will provide you with a table of data, and I want you to create a data dictionary for it. And based on the data frame from above, this is the table I get out. All the columns looking good, data types, all right. I think the descriptions are a little light. And so the next part that we have fun with is going back to that data frame and actually adding more examples in for each one of the columns at a time. So I just say, I will provide you with a column of data, and I want you to update the data dictionary for a more detailed summary of the column of data. And I go from my ID being just a unique identifier for the review to it's a unique identifier that consists of a URL, including the product and the publication, which I know I rolled past it pretty quick, is actually what the ID is. TechRadar is the publication, Razor Opus is the product. So I'm sure you've all seen a lot of this in a number of different settings. It's pretty amazing what this technology can do. As we finish up, I end up actually asking it to dump it out to a data dictionary so I can scrape it up and actually construct a report with it. Now, I'm going to jump to the last piece, which I'm assuming for most of you, you'd be aware. Ray, I will never put my company's data into one of these things. There's a lot of ethical and security concerns, and that's legit. One of the things that we try to do in our coursework is to explicitly talk about the ethics, the fact that the models are biased, the reality that depending on your type of data, it could be writing a biased description describing that data, or the fact that if you're using one of these APIs, it could be pushing that to a third-party source. So we talk about ways to mitigate that. If you have any interest in our educational stuff, I'll go ahead and zoom in a touch. We have the botwhisperer.co that I mentioned, and then we have a few products that we're messing around with at the moment around data management automation, data security tools for large language models, as well as automated usability testing. I'm a big fan of this space, and I'm always open if any of you see me around to have a conversation in the hallways. Cheers.
Thank you so much, Ray. I enjoyed reading the description of publication in your data table saying the name of the publication that published the thing. I just like when you have to describe something, you use that same word like twice in the definition. Anyways, here to take away and helping us to unlearn multiprocessing is Peter.
All right. Thank you, Lorena. Hello, PyCon. My name is Peter Sobot, and I'm here to rant at you for 5 minutes about how you should unlearn everything you know about Python's multiprocessing library. Quick note, if you saw Ukash Langa's talk at 1:30 p.m. today, much of this content will be similar, but as you can see from this forensic analysis, I tweeted about my lightning talk a full hour before his talk started, so really, he was copying off of my slides. I'll buy him a beer. It's all good. Okay, if you're a Python programmer in, let's say, academia or research or some other field where writing software is not your main goal, but rather you're using software or Python to get something else done, you've probably encountered something like this before. You're writing some code, your code is slow, and you want to use more of those CPUs that your computer supposedly has to make your code run faster. And your coworkers or your colleagues might have said, well, you should use multiprocessing. It lets you do that. It says parallelism. It works. Go ahead and use it. And they're not wrong. Multiprocessing is good, it gets the job done, and it's useful. But I'm here to tell you that you shouldn't use it, and you should try other things first, and we'll talk about why. So again, if you're someone who doesn't write code for a living, but rather tries to do other stuff and code is just part of your job, you're probably not familiar with what's happening under the hood when you're using something like multiprocessing. So let's go all the way down to the lowest level we can go to, which is right here, a CPU. Your computer probably has one or more of these, and a CPU really just executes instructions. If you're writing Python, you're probably not writing these instructions directly, but your CPU is executing some instructions. And for this talk, let's say your CPU executes one instruction at a time. Your computer is probably running multiple applications, and what your CPU is actually doing is running some instructions from each application in this kind of round-robin fashion. It'll run some instructions from this app and then this app, and to you it seems like they're all running simultaneously, but that might not actually be true. Now, let's say you might have a newfangled computer that came out very recently, and it actually has more than one of these CPUs. Maybe it has two, or maybe if you're really, really fancy, you have three. And in that case, you still have multiple processes, and these CPUs will execute code from each of these processes or threads simultaneously, so you can get more work done at the same time. And this is what's happening if you use multiprocessing, because, again, the CPUs get to do multiple bits of work at the same time. One last concept to talk about here. If you're new to all of this, one process can actually have multiple threads of work. And the difference here is that each of these threads can share memory between them. Yes, you can also have shared memory in processes, but I'm not talking about that. And all of these can share the same state, the same data. They can talk to each other very easily, very quickly, and so on. So this is how processes and threads work in an operating system. Let's write a very quick Python program to use these threads in an interesting way. So I'm going to make a program here that has two threads. It has some data. It has a do work function. It just runs a Python for loop here, and then we'll write some boilerplate code to actually start these threads. We'll start two of them, and then we'll wait for them to finish and then see what happens at the end. So if I run this code, and we actually watch what happens here, CPU 0 starts executing, and then CPU 1 starts running, and wait, they're not running in parallel anymore, they're actually taking turns. And this is, as many of you in the room already know, because Python is infamous for having a global interpreter lock, this big lock that all these threads have to take when they want to run Python code. That's just the way Python works. I don't want to get into it. I really don't want to talk about it. But it's there. And so we need to find a way to work around this. And again, multiprocessing would let you do that. But there is a hidden cost with this wonderful library. If you want to share any data between these processes, if you want to dispatch work to these processes and so on, it's not free. In fact, usually by default, the data that you want to pass between these processes needs to be serialized or needs to be encoded in some format, usually with Pickle, as you see here. So we'll take this list of two elements, Pickle will serialize it to this really nasty looking string. It has to send that data through the operating system to the other process needs to receive that and then unpickle it and so on. And this takes a lot of time. In my measurements, let's say it takes 20% CPU time to do that, and then 5% to do this, and then 25% to do this. I made these numbers up, but it takes some time. So let's change our program completely here. So instead of running a Python for loop, we're running all of our computation in a different library. So here I'm going to use NumPy with the NP package there, as you see, and all of the computation is going to be happening in that package. Now NumPy has a nice property, which is that it's not actually written in Python. Under the hood, it's using a lot of C. And so it can release the global interpreter lock. As soon as our Python code starts executing any of these NumPy functions, you can see it releases the lock there, and now the CPUs can actually get work done in parallel, and without having to do anything with multiprocessing or anything more complicated like that, we can actually get full usage of all of the CPU cores on the machine. This is a real screenshot of 12 CPU cores, 100% usage, no multiprocessing. And really, all I'm trying to say here is, if you're unfamiliar with this concept, please just reach for threads before trying multiprocessing. That's all I ask. That's it. That's the whole thing. Thank you so much for having me, PyCon, and thank you for listening.
Thank you so much. And I really love the animation when the gill like falling down the boom, and my heart was like broken or something like that. So next, we'll have something that is super fun. As you can see here, Sonny is already ready to give his lightning talk. So you have the energy? Yes. So it's about Pygame. I love games, so I hope you enjoyed it. The stage is yours.
The speed of Mr. Bardess is a person that doesn't exist, at least not in this universe. This is the only time that I will acknowledge that none of the following bio is real. Hello everyone, I am Mr. Bardess, and I'm a luchador in a universe that is almost like this one. While luchadors in this universe is known for physical wrestling, I came from a world where they perform as programmers. So strange. I was accidentally transported here by a strange Python program. I hope that one day I would be able to return to my reality. In the meantime, I spend my time sharing secrets from my universe. And by complete coincidence, that knowledge is also acceptable, applicable in this universe. Let's talk about the global game jam. In 2010, or rather, a game jam is a 48-hour event where game developers collaborate to make a game based on a theme. 48 hours. This is the first time I created a Pygame project. This was early in my career. And yes, let's take a look. I did use stubs. Where is that? There we go. I did use stubs in this project. That's how old this is. So, yeah. On 2010, or 10 BC, before COVID, the game jam theme was deception. And this is the game that I created. Oh, by the way, it's running on Python 2.7. Wow. The game that we created, were three of us, was called Psychic Fighters. Apparently, in the future, there are people who then predict what you're going to do, which has caused problems in the Olympics. How can it be fair if before you do anything, your opponent can predict the future? This is a two-player game, and as I said, it's about deception. You're going to try to deceive your opponent to do something, to expect something else. Now, since this is a game jam, we only had 48 hours to create the game. Psychic Fighters. Let's hit that. Well, Easter egg, here at the bottom are the team that created this game. And I was the only programmer. Here we have on the left, Mr. Muscle, and on the right, Sparkplug. If Mr. Muscle decides to attack, you then see that Sparkplug then see the attack before it happens. Same goes with Sparkplug. And since you can predict, you then block it easily, such as so. So, how are you supposed to play this game? Well, you're supposed to feint. You're going to attack on top, but apparently you're going to attack at the bottom. This is just built in 48 hours, so of course, let's not expect something very important. But of course, we had time to create cutscenes. Yes, this is 2010. And that's the game. Now, I'm actually a teacher, and I also give workshops and talks on programming. And I realized, or rather, I've noticed that if it comes to game programming, people pay attention. I only do game development as a hobby. I'm usually a back-end developer. But my brother and his team was inspired to create Good Night, which is a game you can find on Steam. Where to find Mr. Valdez? I'm part of Python Philippines and also Python APAC. Python APAC has a booth over there at the end, at the community booths. And these are the schedule for Python APACs. I hope to find some of you at Python APAC or in any one of these regions. Thank you very much.
I like the backup of these two talks. They're pretty fun. I also really enjoyed that Aaron shared with me that you do your stand-up comic. That's amazing. Well, I guess it goes right into this talk that you're going to share with us, how not to open source. So let's go ahead and have you take it away.
Awesome. Who's having a good time at PyCon? Woo! All right. Now, who has contributed to an open source project? Let's read the room. Let's rate by claps today. Who's using an open source project? A lot more excitement there. As she said, my name is Erin McHale Staples. I'm a senior developer community advocate at Label Studio and a very online person. Let's see. Alternatively, we could also talk about how not to be an OSS. Feel free to laugh, it's okay. As I mentioned, I'm Erin, I'm a community human. I love open source. I learned to code because of open source. And outside of my day job, I'm a stand-up comedian. First off, if you want to be an open source or an open source jerk, barriers, more of them. We don't have enough. If there's not enough language holding us back, the gender binary or lack of clarity, allow me to make this proposal for the open source world. I want to see obstacle courses. How much more rewarding would it feel like if you knew how many hoops you had to jump through when submitting your pull request? You would have so much more feeling of victory. Next up, acronyms. They automatically update your coolness factor. Like WDYMYDGI. You're all nodding your heads in agreement, obviously. What do you mean you don't get it? You know, as far as I'm concerned, you're having a great time and being awesome at PyCon 23. Confidence is key. Always be holier than thou. Your code is the best code. Always. Because who needs testing? That just takes up valuable time, resources, and effort. Ship it straight to production every time. And on Friday, right? On Friday, right before the weekend, 3-day weekend. And you're all getting the next 2 weeks off. Your team will love you. Open source equals free, right? I love getting paid in stars. The internet doesn't shut off, so why should you? You know, neither should your support team. Having a maintainer is like free support always, right? Thank you all you contributors for building those projects that I'm broke and then issued 47 full requests. We love it. It always works for support. New contributors, no way. I want my same friends, dog, uncles, cousins, neighbor to get involved. And in the words of Drake, who needs no new friends? All logos on your project are always a good logo. This is definitely not problematic. We've definitely not seen headlines like this in recent years. Massive contributions are the only valuable contributions. Who needs a typo correction? Docs? Never mind. Broken links? Don't fix them. Unless you're submitting it with a feature, it doesn't matter. By the way, on those docs, who needs them? Mind reading? More important. I've also come up with a few more lists of things that are more important than reading the docs. Reading minds, post in a forum, yell at someone on Twitter, annoy the maintainers, ask your dog, chat GPT, Stack Overflow, but only if you're replying to yourself with the wrong answer. That's how you get the right answer. And it's probably by some straight white dude who's going to tell you you're wrong. Again, straight to production every time. On one last serious note, okay, put your serious faces on. If there's absolutely one thing you must not do in open source, it's thinking that open source is not for you. So whether you're just getting started or you haven't been a contributor yet or a maintainer, get involved and come say hi. I've got cool stickers.
So thank you so much. It's a really, really cool talk, not of how to not to do those things in open source. But on a more upbeat note, we have our next talk. We have two speakers. We have Laura and Catherine. So are you ready? Oops.
All right, thank you. Oop, am I on?
Okay, there you go.
Hi, I am Catherine Devlin. And one Friday, about 10 years ago, I abruptly and unexpectedly lost a job. And so I spent that weekend desperately trying to prove myself, or prove something to myself, writing a new magic for IPython, namely IPython SQL. It's a magic that lets you, surprise, surprise, use SQL from within IPython, and then get those results, view them, and use them in a Pythonic sort of way. And I like it. It's cool code. I'm proud of it. It is simple. There's not much to it because in the true open source tradition, it stands on the shoulders of giants and uses more awesome packages by others, in this case IPython and SQL Alchemy. So that's cool, but IPython is big and has gotten much, much bigger and turned into Jupyter. And SQL Alchemy is also big, and so the project became popular. And issues started to roll in. And I kept up with those issues sometimes, and sometimes not. And a lot of people contributed code. I really appreciate that. Thank you. But even just incorporating that and governing the project was more than I could really do justice to. I can only get fired once in a while. And so it was a struggle even just to maintain steady state. And really, steady state would be a shame to settle for because Jupyter has exploded since then. Jupyter/IPython in 2013 is nowhere near what it is now, and the SQL magic hadn't been keeping up with the possibilities. So last July, folks from a startup called Plumber formed a friendly fork of IPython SQL called JupySQL, because they wanted to get ambitious with it. And in the 9 months since then, they have put more commits into the project than were done in the 9 years up until that point. So it is time for me to say that IPython SQL has become a legacy project, legacy code which underlies an awesome active project called JupySQL. It has achieved every open source project's dream to graduate from one person's project into an active team project. And so, Laura.
Thank you so much, Catherine. So yeah, I have a chance to learn about the Plumer team about 2 years ago, back when they had started as an open source project. The two core maintainers are Ido and Eduardo. Ido Michael and Eduardo Blancas. And back when I met them, they were maintaining the project on their own time. And about a year ago, they spun up their own startup, which I just joined this year after I was laid off, so it looks like there's a common theme here. So I'm going to show you some of the things that we've been building through JupySQL. So some of the things that you can install this package through pip in Conda, thanks to a recent contribution. To load the extension is a similar logic as before. We simply use a magic load extension SQL. And we've initialized a number of integrations. One of those integrations is DuckDB, which allows you to interact with SQL in a fairly easy manner. Some of the things that we've implemented include the ability to search directly from a CSV file. It also includes the ability to run a query against a JSON file. And other features that we've included includes the ability to do data profiling. So typically we would use pandas describe or pandas.info to get a snapshot of the data. With JupySQL, we can now get the data profiling from the magic itself. And to make things a little bit more interactive, we've added the ability to interact with a query. Namely, we've added a couple flags. So we have an interact flag, which allows us to basically run a widget, and that'll run a query against the database and then update the data as we obtain it. And we've also added this save feature. So just in the interest of time, I'll jump into the last few things. The other two features include the ability to visualize data directly from the database. So we've added a ggplot integration. And the last thing I want to show you is through parameterization, you can do really powerful things. So lately, there's a lot of talk on end-to-end applications, namely having the ability to make a query to a database and then serve those results to a user via a visualization. So I'll exit this right here. So the key feature here is the ability to parameterize my queries. I can make a query against a database, use the JupySQL magic, and then once I execute this, this is going to generate an interactive application. This directly makes a call to the database and generates a visualization. All righty.
Thank you so much. Appreciate that. Really cool project. And for 5 minutes with 2 speakers, quite impressive. We're going to go ahead now and pass it over to Amit, who's going to continue some fun discussions on bots and if they will be our overlords. I don't know. I'll let you decide.
All right. Thank you, Lorena. Hi, everyone. My name is Amit. I am a developer advocate at a small outfit called Retool. We make building internal tools for companies easier. Like all of you, I've been using ChatGPT quite a bit, and I thought that I was honestly getting tired of just opening up my mobile browser and signing into ChatGPT over and over. So I thought it'd be super cool if I could build a text-based system that would just respond to all my curiosities. This was working actually just fine because I used Retool to do this. And the way it works is that I have a Twilio endpoint configured to my Retool workflows, which is really a Zapier of sorts. It just plugs into different components, and it fires off different things. It was working just fine, except that when I landed at Salt Lake City yesterday, I walked out of my hotel, and I saw that it was snowing and it was sunny all at the same time. And it just really threw me off, because that does not happen in New York. So I was super curious. I took my phone out, and I asked GPT what was going on. And it said there's a phenomenon called sunlit snow that was happening at that time. I thought it was super interesting, and I wanted to share that with my wife. So I thought it would be amazing if I could somehow figure out a way that this text bot could also generate some shareable link that I could send with my wife. So I'm relatively new to my Python, so pardon me if this is like super basic, but I needed to figure out a way that I could save the contents of the response from the ChatGPT bot and dump that into some sort of a file buffer. Since all of this is happening in the cloud, I needed to figure out a way to do this in the buffer, and then generate some sort of random HTML file name, and then upload that to some sort of maybe an Amazon S3 bucket. So this is the code that I came up with. It's pretty straightforward. I'm generating some random HTML, and then I create a file buffer using the IO library, and then I get the contents of that file buffer. And then here I am generating a random UUID identifier-based file name. I give it an extension, and then I create a dictionary and pass that on. So this is a basic code. It works perfectly fine on locally. So I need to find a way that I could actually plug this back into my workflow and see if that would work. So here I am. I'm going to go into the generate HTML part of this, and I dumped basically that. I made a few changes because I wanted to get the contents of the response that's coming from the GPT. So I get that over here, and then the next block is going to actually capture that and upload it to an S3 bucket. Now, this is one of the integrations built into Retool. So I'm just going to get the file name, the file data, get the S3 URL, and then send it back to Twilio as a text message. So I'm actually going to do a live demo, and hopefully this will work. So I'm going to ask the same question that I asked it yesterday as I was walking over, which is, how is it that it's so sunny and snowing all at the same time in Salt Lake City? Hopefully the demo gods are with me. It was working, I swear. Okay, here we go. So it gives me this answer, but it also gives me this HTML file that I can click on and send this to my wife. So that's my demo. Thank you. My name is Amit, and have a lovely conference.
Thank you so much. And I wish I have that application as well, because I like go hiking, and then, you know, if I see something weird and I want to know what that phenomenon is, then I would have a clue. So this is our last lightning talk speaker, and Patrick's going to tell us something cool, right? Is your slides ready, or do you not have slides? Okay, so the stage is yours.
All right. All right, hello everyone. My name is Pat Viafor, and I'm going to start with some code. Pretty simple Python. I have some text, an index. While that index is less than the length of some text, I print the text of that index, and I increment the index. This is a loop that just prints out every character of some string. Pretty straightforward. Some people in the audience are going, why not do that in a for loop? I agree. Who likes this better? Okay, half the hands. Why do you like it better? Shout it out. So it's simple, clear. I heard shorter. Okay, who likes it because it's shorter? Show hands. Yeah, it's more readable. I made this even shorter by one character, so you must like it more, right? I mean, and I'm using a list comprehension. That's more Pythonic, right? It's not short enough. This is like 60% short or 40% shorter than my original code. This is 50% shorter. Do we like this? Yeah? Now, the reason we don't like this as much, some of you do, I'm not going to judge. Well, I might judge a little. This doesn't feel right to us. This feels like the wrong abstraction. A list comprehension is for state-free transformations of our iterables. A for loop is for doing something on every element of an iterable. When I'm printing out every character in a line, that sounds like a for loop to me. We've been going down into almost a race to the bottom in some cases, where we keep thinking we need to be shorter code, simpler code. We say simpler, but really we're like, yeah, shorter, and I'm going to jam in all the Python features that I know of. I love the shiny new Python features. I look at the release log every month, like, oh, what's coming up new in Python 3.12? But I feel like this is a race to the bottom, because sometimes we lose sight of why we all fell in love with Python in the first place. And I think the problem comes from a misunderstanding. So my problem is not with the Zen of Python. I love the Zen of Python. I think that there's a very misunderstood line in the Zen of Python. So for those of you who don't know, the Zen of Python is PEP 20, a few statements that are just very indicative of what Python should be. And there's one that's really important. You guys probably can't read that in the back. Let me zoom in. There should be one, and preferably only one, obvious way to do it. And we keep thinking, well, I just showed 4 examples of how code can be, just printing out every character. How is there only one? Is it the most Pythonic features, the more Python features? Is it the shortest code? No. And I think it's because we misunderstand this. There's a word in here we gloss over. Obvious. When faced with multiple different ways of doing something in Python, pick the most obvious. So if there's more than one way, what's the most obvious? Think about it. Think about the abstractions you choose and what communicates your intent the best. A for loop is great for doing something on every element in an iterable. Recursion is great when your problem is composed of similar subproblems. A while loop is you're looping until some condition is true. They all have different intents. The abstractions you choose communicate intent to the future. And I mentioned iteration, but there are more examples of this. When do I use a data class versus a class? When do I use enumeration versus a literal? Every choice you make is an abstraction. Every abstraction you make communicates a specific intent to the future. So as you write code, ask yourself, what am I telling the future? Because writing software is like archaeology and time travel. I'm trying to figure out what happened in the past and communicate my intent to the future. Let your code be a Rosetta Stone. My name is Pat Viafor. You can find me on Twitter at PatViaForever. And if you like these sort of ideas, I wrote a book called Robust Python. Go check it out. Thank you very much. Have a good PyCon, everyone.
Thank you so much, everyone. So that's going to conclude our first day of Lightning Talks. As a plug for Lightning Talks tomorrow, we do have sign up still by the registration desk. Please, please, please do sign up. If you do sign up, the way the process works, since we only have so much space, Chuk and I will send an email to you to let you know that you've been selected. And if you have any questions, you can just continue to correspond with us there. Again, my name's Lorena.
And I'm Chuk. And please remember to check your email if you have right your Lightning Talk there, because if you miss the email, then you will be missing your slot.
Right. So please just, if you do sign up for a Lightning Talk, just keep an eye on your inbox. We'll get those sent out tonight. Have a good rest of your day 1 of PyCon.
Bye for now.